So, in the previous lecture, students, we have learned about the active power, reactive power and the power factor. Now, today in this lecture, we will learn about the power factor correction. We will apply the concepts of the power factor, active power, reactive power to make the power factor or to improve the power factor. Okay. Now, we have seen about the power triangle. So this one is so basically this Vi sin phi, this one will be over here. Okay, so then it will make a triangle. Fine. And this one is the apparent power, this one will be the reactive power, and this one is the active power. So, and we know that the active power P is equal to Vi cos phi, reactive power is equal to Vi sin phi. Now, in order to get the maximum output, as we know that the active power is the output that we get. So, in order to get the maximum output, or in order to improve the efficiency of the system, what we need to do? We need to increase the amount of active power and decrease the amount of reactive power. So how will we do that? Obviously by increasing the cos phi. By increasing the cos phi or increasing the value of cos phi, we can increase the active power, and correspondingly we can decrease the reactive power, thereby increasing the total output power. Okay. So why we will do that? See here, for a constant voltage, okay, suppose we are having a constant voltage source, fine, and you have a load which is demanding suppose P, okay, which is demanding the P amount of active power. Now the voltage source is constant, so V is constant. If the power factor of the system is less, then for supplying the amount of P, the I will be very much, the I will means the amount of current flowing through the circuit will be much more. Again, if the power factor or the cos phi value is very high, then for supplying the same amount of real power, the current flowing through the circuit will be less. And when the current flowing through the circuit is becoming less, then mind students, the I square losses and corresponding several other losses are getting reduced. Okay. So that is the importance of the improving the power factor. Now, let us see that how to improve the power factor. We have seen that there are two types of reactive loads. One is inductive and one is capacitive. But it is to be noted very carefully that inductive load absorbs reactive power and capacitive load delivers the reactive power. In other sense, you can say that the inductive load absorbs positive reactive power, whereas capacitive load absorbs negative reactive power. Okay. So now let us see an example, and then we will understand that how it matches. Okay, how we improve the power factor. So suppose the generator is supplying a power to an inductive load. So as we know that the most of the loads in the nature are inductive loads. You consider motor, you consider fan, refrigerator, pumps, they're inductive loads. So suppose the generator is supplying power to an inductive load, then obviously you can understand that it will have to deliver the real power as well as the reactive power. So the equation becomes S square is equal to PR square plus QL square, if you recall the power triangle. From there you can understand that a square is equal to PR square plus QL square, and power factor cos phi is equal to PR by S. These are the simple vector concepts. Okay. Now see, as we have written, inductive load absorbs positive power while capacitive load absorbs negative reactive power, which means it delivers reactive power. Hence, if we add capacitive load along with the inductive load, right, what will be the change in the equation? See, Sn square is equal to, it is the new apparent power, which is equal to PR square. The active power is same because my load is same. I am not doing any change in the load. So the active power is same, but what I am doing, I am adding a capacitive load, just the capacitive. Okay, there is no active power consumption, considering it to be a pure capacitive load. Okay, so this is a PR square. The reactive power, active power is remaining the same, and what happens to the reactive power? This is becoming QL minus QC square. Okay, so previously the amount of reactive power which would have been supplied by the generator, now what is happening? With the introduction of the capacitive load, capacitor is also supplying or delivering the reactive power which is being absorbed by the inductive power. So the total amount of power, which is total amount of reactive power that is being supplied by the generator, is becoming less. So QL minus QC square. Hence the new power factor is PR by Sn. Mind it is Sn, means the new apparent power. So obviously from the above equation you can see that the Sn is getting reduced because QL minus QC is reduced. Hence the cos phi increases. So that's how we increase the power factor. Okay. So here is a little problem for you. Just think on it, that if the generator is supplying an inductive load and the active power is 100 watts and the power factor is 0.6, mind it, here the power factor is 0.6, but since it is an inductive load, hence the power factor is 0.6 lagging. Okay, the power factor is 0.6 lagging. And how will you improve the power factor from 0.6 to 0.9, considering it 0.6 lagging to 0.9 lagging? Okay, it is not mentioned over there. For your sake, clarity, I am telling that 0.6 lagging to 0.9 lagging. Okay, so I hope you will just think over it. Thank you.